session will be delivered by Professor Dr. T. Subramani, who has more than 20 years of experience, and he has published over 150 research papers and edited 5 journal volumes. He has guided 13 PhD scholars and at present he is guiding 6 scholars. He was awarded 3 gold medals. He was the recipient of Young Scientist Award from DST, India, and he has awarded with Wenlock Award from Anna University. He has organized 14 national and international programs, and he has delivered 71 guest lectures, and he has published more than 11 papers which is having an impact factor of greater than 5, and 3 papers which is having an impact factor greater than 10. So we have a very dynamic and eminent personality in front of us. Let us see. He is going to present on data presentation. Sir,
thank you, madam. Thank you.
One more point I wanted to add here. Recently has got one citation award. So I request Subramaniam sir to just say about that award first, then you can start.
Last I will tell, madam. I have some slide. Some slide is there.
So he has got the best citation award. So that he will tell at the end.
Thank you. So at the outset, I would like to thank the organizers, particularly Umarani madam, Soundarnai madam and Soba madam for giving me this opportunity to share some of my ideas. So the topic is data presentation. So morning, I think already 2 sessions are over related to this topic, data. So first we have to know, so whether it is data or datas. So we have to collect datas. Most of the people will tell, so it's wrong, isn't it? Data itself is plural. You should not supposed to tell datas. Similarly, software or software packages, you can tell like that. Then what is the difference between data and information? Data and information. So meaningful data will be generally called as information. For example, so data may be in the form of table or in the form of text, sometimes in the form of say figures. So sometimes you may not be able to understand. So if it gives some kind of meaning, then it will be called as information. Okay. So what we are going to do is, we are going to process the data. Information can be otherwise called as processed data. I have a lot of examples, I will tell you. Then this is the data processing cycle. So first and foremost thing is, we have to collect data, then we have to give data input, then data processing and storage, then finally we will go for presentation or output. So here you can see the order. So the data is in the lowermost part, then you have information, then you have knowledge, then you will get the wisdom. So if you go in depth into that, then finally what we are going to do is, we are going to take action or we are going to implement the work. Then of course you may be knowing about all these things. So input, output devices, and also some devices will act as a kind of storage device. Okay. So lot of devices are available, right, for giving input, for analyzing the data, and also to get the output. So these are all some of the devices. I don't want to go deep into that. So some devices will be used for, sorry, I think so some devices will be used for giving input. Say for example, scanner, digitizer. You might have heard about digitizer, scanner. So for different kind of input, data input, we will use different kind of devices. For example, if you scan something, so what kind of data you will get? Data will become image, isn't it? What is image? It is nothing but it is made up of pixels. What is pixel? It is nothing but the picture element, isn't it? In each pixel you will have value. Some value will be there, right? So if you use digitizer, your data will be in the form of vector mostly, isn't it? So we have different types of data. We have different types of devices. So in addition to this, we have a lot of devices. For example, if you ask civil engineer, even total station can act as a kind of input device. Your GPS can act as a kind of input device. Okay. Then presentation of data. So this is our topic. So data presentation. Is it okay? Okay, madam? Adi parval. Okay, right. So coming to the data presentation, so we have different methods. So we have lot of methods to present your data. Okay. So here you can see some of the methods, right? You can present your data in the form of table, simple table or complex table, and using some software you can go for graphical representation of your data. So like histogram, like line chart, scatter plots, then bar chart, you have n number of data visualization and presentation techniques. So here you can see there are a lot of methods. So you have to choose which method will be suitable to present your data. Okay. So nowadays lot of software packages are available. Say for comparison, sometimes we will use this type of charts or figures. So for trend, we will use some kind of charts. Say for parts to whole, we will use some kind of graphical representation. Say relationship or some kind of correlation, we will use some kind of outputs. Like that you have lot of presentation. I will give you case studies so that you will understand easily. Then I think all these things you may be knowing. Data types, we have different types of data. So primary data, secondary data. Okay, primary data means you are going to generate data. You will be directly involved mostly, right? Secondary data you will be collecting from various agencies or already published data can be a kind of secondary data. Then qualitative, quantitative, vector, raster, spatial, non-spatial, digital, non-digital, like that you have different types of data. Then normally I used to compare data with fuel used in a car. Okay, see here hardware, to process the data you require some kind of hardware. Mostly you will be using computer. Okay, computer, and for output and storage you will be using other devices. Computers, printers, plotters, projectors will use lot of hardware devices to handle the data. Okay, like a car. You have excellent car. Okay, you have excellent computer. Right. Then software. Software is required to process the data. Right. So you may have licensed software, latest version like GIS, SPSS, AutoCAD. You have so many software packages. Okay. But the thing is, definitely software is going to give colorful output. Right. But what about the accuracy? What about the reliability of the output? Is more and more important. So in computer science, people will be using this garbage in, garbage out, isn't it? GIGO. If you give nonsense data, definitely you will get what kind of output? Definitely your output will not be correct. So what kind of data you are going to give as input? Accordingly you will get the output. Then data. Data can be compared with fuel. Fuel in a car. So what kind of fuel you are going to use? Then you need a trained people to handle the software or to handle the data, like driver. Then the environment, working environment, lab setup. Here you should have smooth roads. Okay. Suppose you have everything perfect. You have excellent car like BMW or Audi car you have. So you have excellent software system, you have excellent driver, you have excellent road. Instead of petrol, if you put kerosene, what will happen? Your car will run smoothly? No. Suppose you have excellent fuel also. Driver doesn't know how to drive the car. Then what will happen? Same thing. If you are not knowing how to handle the software, then our hardware, again it's a problem. So you should have enough knowledge in your particular field. So I have another example to tell you. So this is the project which was implemented maybe 10 or 15 years back for Tamil Nadu government. I will tell you what happened in this. It is a kind of recharge project. So the aim is we have to locate check dams across the river channels to improve the groundwater source. So this is the objective. So what we have done, we have involved so many people. Okay, computer science engineers, civil engineers, geologists, so many people involved in this particular project work. Okay, they handle different type of data, spatial data, non-spatial data, they have integrated. Then finally they got output. Okay, then they went for ground verification, ground truth verification. So what happened, few check dams or many check dams were located across the roads instead of river channels. You should not supposed to construct check dams across the roads, am I right? So what is the problem? Everything is perfect, you have excellent data, but what happened? The interpretation part. The reason is the person who handled the data, He was not able to differentiate road and drainage or river channels in the satellite image. So that is the problem. That is why, so few check dams were located across the roads instead of river channels. Then at the time of ground truth verification only, we were able to identify. Then we have to repeat some of the things, isn't it? So that is why, so your subject knowledge is very, very important than the computer knowledge while handling the data. Am I right? Okay. Now, when you talk about presentation skill, okay, so sometimes say how to present your data in thesis, how to present your data in journals, how to present your data in conference, then how to present your answer in examinations, then interviews. Okay. Say in the case of thesis, you can write 200 pages or 250 pages. There will not be any restriction, isn't it? So you can have n number of figures, n number of tables. But here, when you come to this journal, what will happen? Restrictions are there. Maximum you can go up to 20 pages or 22 pages. And in some journals like elsewhere, so you can put only 10 figures and tables put together. They will not allow to include more number of figures. Then this is the problem, another problem. Then next will be the conference. So next will be conference. So mostly you will be given 10 minutes. Okay, generally what will happen? You will be given 10 minutes time. Then 5 minutes maybe for questions. Only 10 minutes will be given. So how to present your data there? Okay, so you cannot put more slides. You cannot put 100 slides. So less number of slides. Then you should avoid lengthy introduction. Say water. Suppose I am going to talk about water. I need not give introduction about water. What is water? What is its composition? I need not tell much about, because 10 minutes time will be given for you in the case of conference, right? Then examination. Suppose you are writing some competitive exam. Again, how to present the data? Your answer is very, very important. Okay, because I have cleared so many exams, both written and I have appeared for interview. UPSC, TNPSC, TRB, non-UC exam. I have cleared so many. If the question paper is easy, then it will be very difficult to present your answer, because everyone will be writing the answer, because everyone knows answer. So your presentation skill is very, very important. Okay, you should include more flow charts. You should express your answer in the form of, say, diagrams, figures. Then only you will get the maximum mark. Then many people will write in the form of paragraph. Very difficult to read the paragraph. So if you are writing in the form of paragraph, please underline the important keywords. It's very easy to correct your paper, and also you will get more marks. Okay. Then finally interviews. Again, how to present. So many things people will observe. One example I will tell you. Even some interview panels, one person will be sitting. He will not ask any question from beginning to end. Psychologist will be there. In some interviews, okay, he will watch how you are behaving. You will enter into the hall, no? Someone will say good morning, sir. Someone will say good morning, sir. Someone will say, he will observe everything. He will never ask questions. Okay. So I will tell you, when I was attending this TRB exam, at the time there was only one post in Tamil Nadu. Okay. So we cleared the written exam, all this descriptive type, everything. One post they called 3 people for interview. Okay. So I attended the interview. So they will ask some questions. We have to introduce ourselves. Then they will ask questions. Then they have given 5 minutes time to teach about the subject dam construction. This topic was given. Then board was available, chalk piece was available. Then I explained. So with figures, okay, I put some diagrams. Then I explained. Then they asked some more questions after that. Then finally they said you can leave. Okay, you can leave now. So what I have done, no? After telling that you can leave now, what I did, I erased the content in the blackboard, right? Then I said thanks, then I left the hall. This will make lot of what is difference. So the previous person who was interviewed, no, he didn't erase the board. Of course, tunnel construction was given for him. Tunnel, everything were there when I was taking the class. So this will make lot of difference. Okay, you can score more marks. So presentation skill is very, very important. So when I was in GCE Salem, I was the placement coordinator. Many students will clear the written exam, but they will fail in the interview. They will not be able to answer the questions in a proper way. So this is very, very important. So presentation skill will vary. So way of presentation will vary. right? Then coming to the thesis, so you can have any number of chapters, but generally the first chapter will be mostly introduction. You should have clear methodology, clear objectives and need for the present work. So you have to mention these two important things. Then literature review. So if you really do a good literature survey, definitely you can publish one paper. Okay, review paper you can publish from this particular chapter. Then third chapter may be methodology or methods and materials. Then your core chapter will come into the picture. So you can include 2 core chapters or 3 core chapters or 4, maximum you can go up to 4 core chapters. Then you can go for summary and conclusion. Then here you should give recommendations. This is very important. Then scope for future work. So minimum 5 papers you can publish from your thesis. If you are able to publish 5 papers, definitely your thesis will be very good. You have done excellent work. Okay, in good journals, right? Then coming to the conference, I told you 10 minutes time will be given. So you will be talking something. Then people will be asking the questions. So what happened when I was attending this conference held at Rajasthan University, one person from Tyagaraja Engineering College, he presented some kind of data. So the experts sitting in the front row, they were asking questions. How can you say your data is correct? He has done some analysis related to water quality data he is presenting. They are simply asking, how can you say your data is correct? He was not in a position to answer. He said, I myself went to the field, I myself collected the sample, I myself did. So I have done analysis in the lab. So all those stories he is telling, but the people were not interested to listen. Okay, then I told, very simple thing, you go for ion balance error, maybe the chemistry people, even you might have done. So in water, positive ions will be there, negative ions will be there, isn't it? You add all the positive ions, you add all the negative ions, then you find out the difference. If the error is less than 5%, you can tell that your data is correct. Nobody can blame you. Then all the people have accepted. So like that, they will ask questions. So another question, so this one. So when I was attending some kind of conference in Mexico, this question was asked. So he has presented his data in this form. One person has asked, so you generated this kind of output using some kind of software, SPSS software. So how can you say your software has given correct output? Isn't it? Some algorithm will be there. So how can you say you got correct output? So again that person was not able to tell the answer. So here is a kind of correlation matrix. So you are comparing or relating 2 parameters. So in the software itself you can see, if you compare mg with mg, you will get 1, isn't it? So in x-axis and y-axis, if you take same parameters, definitely you will get the coefficient 1. Am I right? The software is giving, you see, 1, 1, 1, 1. If you compare same parameter, Na versus Na, you will get 1. TDS versus TDS, 1. Say CL versus CL. So this is the kind of validation. Am I right? So you have to tell these kind of things when you present some kind of data. Definitely they will ask, right? Then of course our Honorable VC was telling about this. So if you want to get more citations, definitely you have to link with any of the topics. So environment, energy, health, agriculture and recent upcoming fields. I have case studies in all the fields I will give you. Then coming to the data, so you should not supposed to provide raw data. You should not supposed to provide raw data in journals and papers. See, when I started my research in the year 2003, I have presented raw data in this paper. So before this one, I attended one conference. One professor from Shinsu University, Japan, he also attended the conference. Then I requested him, so I have samples. So in our university, we don't have XRF. Sir, can you analyze the data and can you send me the results? He said yes. Then I sent the samples to Japan. He did analysis and he has sent the data. Okay. Then in the paper, I put the raw data as such, you see, all the values. Then he told you should not supposed to give the raw data. Why? Anyone can change the numbers simply. Am I right? Anyone can very easily change the numbers. I took a lot of effort. I sent all the samples to Japan and I got the result. Then I interpreted the result. So if you give raw data like this, then anyone can very easily copy and they can simply change the numbers because generating data is not easy. So you should not do this mistake. So you can present your data in a different way, say like a statistical way, say minimum, maximum, average, mean, mode. So they cannot copy the data as such. Then another important thing is the methodology flow chart. Methodology can be expressed in the form of flow chart. So by seeing the paper, immediately someone can understand what kind of work is there in that particular paper. Okay, if some paper has come for review, what I will do, I will check the figures, I will see the methodology, then immediately I will come to conclusion whether this paper is worth to publish in that particular journal or not. Immediately. Okay. So here I have example. So this work, you will not believe, this work was done by a group of BE students. Okay, they have collected data and they have done some analysis, and then finally we published in this journal, Environmental Monitoring and Assessment. It's a very good journal, though the impact factor is less. You will get a lot of citations. It's a very good journal. So here you can see how they have presented the methodology. Here all the components are there. You see, here you have primary data. Here you have secondary data collected from various government organizations. Then they generated data by doing experiment or analysis in the lab. Then, so they have interpreted the data using various software packages. Then they have gone for some computation of health risk. Then result and discussion. Then finally you have to give your recommendation or what is the solution for the problem. You have to give in this way. Okay. So by seeing this methodology, one can understand what is there in this particular paper. So they have published another paper. You see, this work was also done by UG students. Okay. You see the impact factor 6.3. It's another good journal, Ecotoxicology and Environmental Safety. Then title should be very catchy, right? You should use, say for example, this is Tirupur region. You can use this word, textile hub, trans city, or white city, cement city. Like that you can give attractive names or words in the title. And this title should match with this particular title of the journal. Then only they will take your paper for review. Okay. Then this pie diagram and charts. So morning you might have seen this. So sometimes you will prepare these type of pie diagrams. So for example, so here in this pie chart, so I have used the land use pattern of the year 2002. Then I have prepared the land use pattern for 2012. Then I have compared. So what happened? For example, urbanization. Chennai. How the Chennai city is growing, in which direction it is growing. So which parameter is converted into some other parameter. So you can compare this. For example, you take this. Here the value is nearly 30, 27. What happened here? 7.55. So that means some land is converted to some other land. For example, Chennai, if you take the very old data, so you can see more number of water bodies. What happened now? Concrete jungle. So all the water bodies are encroached. Am I right? So those kind of studies can be expressed in this way. It's very easy to understand. Then next important thing is, so during my PhD work, I have published this paper. Nothing new in this paper. So what I have done literature survey. I have collected so many journal papers published by good people working in this particular field. It is very simple to understand. So water, whether the water will be suitable for drinking and irrigation. This is the title of the paper, you can see. So what I have done is, so I have seen so many methods used by so many people in different parts of the world. What I have done, I have data. What I have done, I have applied all the methods. Then I have presented my data. In this paper, it has got 650 citations, you cannot believe. In the year 2005, I published. So after 17 years, now also people are referring this paper. Nothing new in this, but you see how many citations I am getting. So this is very important. See, so many tables I have prepared so many diagrams. Okay, so then I have published this. The next important thing is, so you have to combine figures and tables. This is another important thing. So very simple example I tell you. So you all know about this rainfall. I have to do some kind of rainfall analysis, everyone can understand. So here you can see 9 figures in 9 charts in one figure. So this is monthly variation of rainfall, how the rainfall is changing monthly in different places. This is for Erode region, Gopichetipalayam, this area. Then next thing, here you can see this seasonal variation. What about monsoon? Monsoon wise, how the rainfall pattern is changing. For some decision making, this will be useful, isn't it? Chennai is affected by flood, cyclones. You have to do this kind of analysis. Then spatially, how it varies. Rainfall intensity, how it varies, right? With respect to time and space. Then frequency distribution of rainfall. You have to combine. Then only it will be easy to interpret or understand, right? So I have some other example also. This paper is recently published. This is related to energy. If anybody is working in this field, you can publish papers in this journal. Excellent journal, Fuel. You see the elsewhere. And impact factor is 6.61. So here, so how we have presented our data, right? This is the spectral profile. So we have studied the sulfur impurities in the commercial coal. So we have collected a lot of coal samples, we have done the experimental work, then we have presented our data. So you have to keep all the figures in all these kind of spectral profiles in one figure, then only you can correlate, you can understand. Then this is the same image, you have to keep like this, then only people will accept your paper, right? So if you write everything in the form of text, nobody will accept. Then this will be useful to the mining industries and also the energy sector. Then another thing is, sometimes you will put this kind of words in the title. Say here I have used geographical information system and some kind of multivariate statistical analysis. So this is why I have given this title is, this geographical information system is a kind of software anybody can use, even politicians can use. This is the software which can handle any kind of data. If you have spatial data, if you have non-spatial or attribute data, you have vector data, raster data, anything can be comfortably handled by this geographical information system. Of course, in different places people will be using different names. So in some places it is called as urban information system or land information system, but everything can be brought under single umbrella geographical information system. So you can get excellent outputs. You can do analysis, you can do prediction, you can do modeling. So many things you can do with the help of this particular software. This is the output, simple output. So here you see how many maps are there, 12 maps in one figure. So by seeing this figures or this diagrams, you can immediately understand what is the scenario there. Okay. So these are all some kind of water quality parameters. All are water quality parameters. In one chart, electrical conductivity will be there, another chart, this diagram, sodium will be there, potassium will be there, like that. I have presented all the diagrams in one figure. And you have to give proper color. Another important thing is, many times research scholars will do mistake. So when you give red color, immediately your mind will think something is wrong in that area, isn't it? So if you see red color, so the quality is bad in that area, immediately you will understand. So here you see, if you take all these maps, you see the red color is less, but here you have more red color. That means something is there, some kind of pollution is there. This is for phosphate and this is for nitrate. Then you can analyze what is the source for that. Then mostly the fertilizers used for agricultural activity, right? So this is the source for this kind of pollution. So this kind of spatial representation you have to do. So very easy to interpret your data, right? Then one more example I will give you for spatial representation. So everybody is talking about this interlinking of Indian rivers. So if you don't go for this kind of spatial representation, you cannot implement this work. You may have a lot of data. For example, if you ask Tamil Nadu government, government will give enough data for Kaveri basin. Then you can get from Andhra government, you can get details about Kaveri, say Krishna, Godavari. But how will you implement this work? You have to go for spatial representation. So then only it is possible to implement this. Particularly various disaster related studies, what you should do is, you have to go for spatial representation of your output or data. So I have some case studies for this. So some studies were carried out in Noyal River. You know, this is the highly polluted river in Tamil Nadu. This Noyal River is the highly polluted river in Tamil Nadu because it passes through industrial area, right? You see how we have presented our data. So if you want to present your data, initially this is the Noyal River. This is the Noyal River system. You should give index map. Okay, you know about Noyal. I know about Noyal. Somebody is reading your paper in Russia. They may not be knowing where this Tamil Nadu is. They may not be knowing where this Noyal river is. They may not be knowing, so you have to give the index maps. See Tamil Nadu. So this is India map. So this part of area we have done some work. Again this is Tamil Nadu. In this Tamil Nadu, so this river is somewhere here. So you can see this. So this index maps are very, very important. Then location, this latitudes and longitudes are very, very important. So this very, very, suppose somebody is asking you, where are you now? What will you tell? I am sitting in this building, CFR building in Anna University, right? Tamil Nadu, India. Then Milky Way galaxy. Suppose your research area is in Bay of Bengal. What you will tell? Suppose you are collecting samples in Indian Ocean. We are doing a lot of research also. Somebody is calling from say Japan and asking you, where are you now? What will you tell? I am in Indian Ocean? No. How will you tell your location? In the form of latitudes and longitudes. Anybody can understand, isn't it? If they Google, they will get the exact location. So that is why you have to give all these kind of things. Then another important thing is, so here what we have done is, so we have divided this entire area into so many regions. Normally people will not do. You can refer papers. What they will do? Simply they will present the data. Here what we have done, we have divided into so many regions. For example, region 1, region 2, region 3, region 4. Then you have to address your problem. So for example, region 1 is Coimbatore area, you have a lot of metal processing industries. Am I right? Then you come to Perundurai, you have Sipcot. So if you come to Karur, you have a lot of textile mills, paper mills. So sources are different. Okay, you have to present your data in this form. So dividing the area into various industrial regions to address your problem. So then another important, so then next is, you see, you have to collect sample locations. So yeah, we have collected samples from all the areas. Then after that you have to present like this. So here you can see, I told you should not give the raw data. So region wise we have given minimum, maximum, average, right, for various metals present in the water. Then comparison in the pre-monsoon, before rainfall, after rainfall, and you can see the color. By seeing this, you can anyone can understand what about the status in the case of chromium. So what about in the case of copper? What about in the case of nickel or zinc? Anybody can easily understand. Okay. Then next important thing is the correlation of data. So here, normally if you want to get relationship between two parameters, generally you can go for this one. Simple Excel scatter plot. You can use Excel software to prepare scatter plots. So in x-axis you are taking one parameter, in y-axis you are taking some other parameter, and these are all the samples, and you will draw the line, best fit line, and you will get the R square value, isn't it? Coefficient value you will get. So by seeing this value, you can understand. Sometimes you will get positive correlation if it is like this, and if the graph is like this, it will be negative correlation. So sometimes you will present your data like this, right? Then this is another example I will give you. Here, in addition to this, we have presented the data like this. Okay, so this indicates rainfall, and another one is runoff. Same scale. I am using same scale to represent two parameters, right? So what happens? So how much rainfall is happening in that particular area? How much goes as runoff? How much water is infiltrating or percolating into the subsoil? So for that purpose, I have prepared this kind of chart. It is very easy to understand. Suppose you have three parameters now. How to compare? Again, you can use your Excel chart, right? So three parameters here. I have compared three parameters. So here in this axis, you can see the month and year. In this axis, you have rainfall. Here I have included one more parameter, is water level. Three parameters I have compared here. Okay. So you can use these kind of charts for your problem. I am giving just example. Here, another beauty is, you see the values are increasing here. 0, 50, 100. But what about this side? It is decreasing. 0 is on the top here. 0 is in the bottom of the scale. So this is how we have to use, because I am going to compare this rainfall and water level. So water level is the depth of water available in a particular area. So what will happen if rainfall occurs? More amount of rainfall will percolate and water level will come up, isn't it? So it is very easy to understand. For example, here what happens? See, after rainfall, suddenly the water level has come up. Water level has raised. you can very easily understand. If you put the value 0 here and 0, 2, 4, 8, then it will be difficult to understand. Normally people will present their data in that form. So we have presented in a different way for easy interpretation and understanding. Okay. Then some other journal, Environmental Science and Pollution Research is another journal, good journal. So we have done in this way. It's very easy to understand the data. It's a way of presentation of your data. Then suppose you have more number of parameters. 2 parameters, then we compare 3 parameters. Suppose you have 100 parameters, 1000 parameters. How to understand the relationship? You can go for this correlation matrix. So you can simply use SPSS software package. I think you may be knowing about SPSS, isn't it? Statistical package for social science. So very easy to handle because menu driven commands will be there. You can very easily learn and you can use. So you will get this kind of matrix, right? So these are all the coefficients. So here the value will be between +1 and -1. If you have excellent positive correlation, your value will be +1. If it is excellent negative correlation, suppose I am taking more number of classes, what about the result? People are getting poor result. Then what will happen if you compare these two? It's a negative correlation. If I take more number of classes, if students score more marks, then it's a positive correlation. Based on this value, you can understand. So here in some cases you can see 0.99, almost 1. Excellent correlation between these parameters. That means if this parameter increases, this parameter is also increasing. Negative correlation means if one parameter increases, the other parameter decreases. By seeing this, you can very easily understand plus and minus values. Then one more way of representing the correlation. This is another, using software you can present this. Present in a nice way. People will expect these kind of outputs. Right? Instead of giving the values in the form of tables, now you see this is another good journal, Environmental Geochemistry and Health. Right? So we have presented the data in this form. It's very easy to understand. Graphically, even you can see the graph here. So bar chart or histogram is also available. You can see the values. It is very easy to understand. Then next one is a very high impact factor journal. You see, impact factor is more than 10, 10.6. Hazardous materials. Okay. Then title should match with this. So hazardous. So some word hazard should be there, isn't it? Materials or metal should be there. So you have to properly write the title. Then here, so simple study we have done during COVID time. So COVID lockdown time. So what we have done is we have taken this river. So it is flowing in Salem area, Tirumani-Muttar river. So we have collected samples. I told you about index map. You see, anybody can understand. So this work is carried out in this particular region of Tamil Nadu. Tamil Nadu is here. This is the India map. Anybody can easily understand by seeing this. And where I have collected the samples, it is clearly given. Then here you see before COVID-19 lockdown and during the COVID-19 lockdown. This is a comparison. So you all know that during lockdown period, all the industries are closed. So industrial discharge is almost zero. Then what happened to the river system? Whether the quality of the water is improved or not. So by seeing this figure, you can very easily understand. You can very easily compare. Okay, red, then yellow, then green. Here in this you can see a lot of green. So by seeing this, you can very easily understand. I told you have to give proper colors. You have to use proper colors. Then one more method of expressing the correlation. This is another graphical way of representing the correlation matrix I have shown. No, this is another way of. Then here the color scale is very important. In some papers, I will not be able to see this color scale. Without color scale, they will present. Then you will not be able to understand. Am I right? So here you see, if you are able to see this color, it is +1. If you are able to see this color, red, it is almost minus, negative correlation. So color scale is very, very important. Then this is another way of representing your data. Cluster analysis. So cluster, and sometimes you will go for this type of cluster analysis, grouping. Right? Then next, one more important thing. This is another important journal in exposure and health. So Springer, impact factor is 11.5. You imagine. So our honorable Vice Chancellor was telling, if this word is there in health, then more people will refer. More number of people will refer. So if the health component is there. So that is why we have chosen this particular journal to publish our work. So here definitely health should be there because journal, it should match. Then, so we have done some work in Sivagasi area where you have a lot of fireworks, right? So they are producing crackers. So definitely it is going to pollute the water and also groundwater. So we have collected samples. Then again when you talk about data collection, so you can go for random sampling or grid sampling. In different ways are there to collect sample. So it's the random sampling we have done. We have collected samples from all the areas, you see. Then only you can represent in a spatial way. Now you see, if you see this output, right? So here in this area you have red color patch. So we have computed this hazard index, total hazard index, and we have expressed in the form of spatial diagram. So here you can see this red patch because in this area more firework activity is going on. So that is why, so this area is highly polluted. So by seeing these kind of graphs, anyone can very easily understand your output. Then here you see this is a simple Excel chart, but it gives a lot of meaning. So in no journal paper I have seen this kind of representation. First time we have presented our data in this form. So you have to think, so how to present your result, right? So here what happened, so this is one axis, this is another axis. So what we have done is we have generated data, we have collected samples from open wells, we have collected samples from bore wells. So we have presented our data in this form, right? Red color means it is very high risk. So this one high risk, this one safe. So now by seeing this particular output figure, you can very easily understand that open well water is highly polluted when compared with the bore well water. But unfortunately in this area, so people are using open wells for drinking water supply. Okay, but what we can suggest? We can give our suggestion or recommendation to the administrative people, please don't use the well water for drinking water supply. So because the bore well water is good, so instead of using this water, you can go for this water. Right? So by seeing this you can, otherwise if the data is available like this, it's very difficult to understand. So we have collected so many samples, 46 samples from shallow wells and 28 samples from deep wells. But unless and otherwise you generate, or if you present your data like this, you will not be able to understand the impact or the importance. Then this is another paper in Taylor and Francis. So this is a spatial distribution again in this form of charts. Then this will be useful to the mining industry. Then one more thing, so this paper is having more citation, nearly 300 citations it got. So the reason is, so I have manually prepared these diagrams. Manually I have prepared. So this was published long back, I think in the year 2010. So at the time, if you want to publish color outputs, they will ask money. You have to pay in dollars, then only they will publish. So what I have done, you see all the maps, diagrams are black and white. So what I have done, I have prepared cross section. I have to prepare the cross section, but computer software will not give this kind of output. Say for example, this may be Tenkasi, this may be Tirunelveli. So what happened below? So I made sections like this from the data. Manually I have prepared. With the help of a graph sheet I have prepared, then I have given different symbols, then I have published this data. So many people have appreciated this by sending mails. So you have presented your data in a new way. So this will be very much useful for the further work. Like that they have given comments. That is why this paper is having more citations. But computer will give this kind of output. Now some software packages are available. You can get this type of output to get some kind of 3D. Then here, shall I take a few? So here you can see in this paper, so I have collected 7 years of rainfall data. I have presented in the form of charts like this for different places. Say for example, Tenkasi, Senkotai, so different areas in addition to this spatial. By seeing this one can understand. This is about the soil condition. So how much sand is there, how much silt is there, how much clay is there, one can understand. So this will be very much useful for implementing your work. For example, I am interested to dump the waste, municipal solid waste. You can understand which site will be suitable for me. So if you have sand, you should not supposed to dump the waste because more amount of pollutant will enter into the subsurface. So if you have clay, yes, you can prefer the site. Suppose I am working on some other project, say recharge. So if you have sand, what you will do? You will identify the site for putting check dam. If you have clay, you will not do that because clay will not allow the water to percolate. So purpose, According to your purpose, you have to do the work. Then is another journal, Sustainable Cities and Society. It's a very good journal. Okay. So city, if you do some work in a particular city and your work is related to society, you can choose this journal, excellent journal, Elsevier journal 7.6. Okay. Here you have to coin the words, healthy society. How your work will be useful to for the improvement of the society. Okay, food protection and drinking water supply. So here, so you have to use many proxies to address your problem. So in many papers what they will do is they will take only one method or one proxy and they will come to the conclusion. You should not supposed to do like that. You can use many proxies and you have to give the reference also, then finally you have to present. Any kind of work can be presented. You see, I have taken this paper from our Vice Chancellor's profile. You see, he has done some experimental work and he has published paper in this journal. You see, it's an experimental study he has done. Then another thing is, so in this my objective is different. I have to identify the location for drilling oil wells. So in this particular study, so I have to concentrate more on location and direction. Direction is very important for me in this case. For example, if you want to run a flight from Chennai to some village in Japan, you have to give more importance to distance or say direction. Direction is most important thing, isn't it? If your direction is wrong, your flight will not reach that particular place. So same thing, here we have to give importance to the direction. That is why we have represented the fractures in the rocks. Okay, where the hydrocarbon or oil will be there. Okay, otherwise what will happen? If you drill a well here, normally you say your oil will be available 20,000 feet or 25,000 feet below. If you drill, after that if you are not able to get oil, what will happen? You will be wasting lot of money. So this is very important. That is why we will represent like this. Then you can identify the suitable places. Then another important thing, in some journals they will ask this kind of graphical abstracts. This is another way of presenting your data. In some journals like Nature, if you go to the journal like Nature, they will ask this kind of graphical representation of your abstract. You have to clearly represent this abstract. Right, this is the abstract. You see, by seeing this abstract, you have to explain everything. In many journals, they will be asking this kind of graphical abstract. So it may be experimental study or whatever the work it may be. You see, you can start from here. So what are the sources, what are the pollutions, then we are collecting sample, people are using water for bathing and drinking, then collected laboratory analysis, then we have calculated hazard quotients, then finally remedial measures. Everything should be there in one figure. If you know CorelDRAW, comfortably you can draw all these diagrams or figures. Then another thing is schematic diagrams. This is also very important. Manually you can do. Then using computers or software you can prepare these kind of schematic diagrams. Okay. You see here what are the sources, how it is related with the process, natural process, water cycle. So you can represent like this. Because time is already over, quickly I will go through. I will finish my slides. Then sometimes you have to cite your the paper already. So we have published similar kind of, we have presented our data in this form in some other journal, so we have to quote that. Then another way of representing this is nothing but box whisker diagram. So for any kind of result you can use this. Then dendrograms you can use, right? Then principal component analysis, factor analysis. You can go for principal component analysis or factor analysis and you can present your data. Then in the form of 3D model sometimes you can present your data so that anyone can understand, right? Then next important thing is another good journal. So here what we have done is we have computed our computed health risk, then we have presented our data in this form, then we got the graph. Then what about the real scenario in the field, whether your output is matching with the field scenario or not, you have to verify. Definitely journal people will ask. Then here, so I am telling that these samples are under risk. If you use these samples, definitely your system will be affected, fluorosis will come. Like that I have given. But what is the proof? You see, photographs. So if you go to the high impact factor journals, they will ask, so these are all the dental fluorosis at different villages. You have to give the photograph, field evidence, age wise, how it is affecting. You have to give your field photos are very important sometimes. Or suppose you are doing some experiment in your lab, so you take photos. It will be very much useful. Then if I want to do some kind of work, already some work is done already in that particular area. So you have to include that also. Then only you can give your ideas. So these works were already carried out in that area. What I am going to do, new thing in this. Then this words I told you is another good journal, environmental research. So is the leather tanning industry, chromium pollution we studied. Then field photos, you have to present the field photos. So here when you talk about the data collection, whether you have to get permission from the authorities or not. Sometimes you will get permission, sometimes you will not get permission. You should not get permission. If you go with permission, what they will do? They will run the treatment plant and they will give the output. Nothing will be there. Pollutants will not be there. Next day they will close the plant. Okay, they will simply discharge the effluent into the river channel. But another thing is you must be very careful. What they will do? What they will do? Without permission. They will never allow to collect the sample. I had some kind of experience. Okay, you will not come back with your phone, camera or your cell phone. So that kind of problem will also be there. But so being a scientist or researcher, we must do this. Then of course we have almost we are going to get a patent from this. We have used some kind of novel technique to say reduce the hexavalent chromium, toxic chromium to some trivalent chromium. We have used bacterial biomass, some kind of bacteria. So if you have new process or new product, you can go for patent. It will take long time. Then two more topics are there. I will quickly run the slides. Then another important thing is our research work should be useful to the people or society. I have some two case studies, right? So we have done some work in Palamalai area where it is very close to Mettur or Salem area. So tribal people were demanding for roads for more than 50-60 years. Nobody was interested to conduct survey because Sandalwood Veerappan was living in that area. Then we conducted survey, we have given the output, and of course we have published the data. Then here you can see this is the scenario. They don't have any hospitals, schools were not there. Then this is the existing road for them, footpath. Then we involved our students. We have to involve our students, then only they will learn. UG students, PG students, they will learn. Then we have given the output, then we have given the data. We got permission from the authorities. We have to get clearance from Environmental and Forest Board, and they have marked the trees, and now they have implemented this work. After submitting this, they have implemented this work. So now the people are getting benefit. We have to involve the beneficiaries also. We have conducted some kind of tribal development program for them. So they are very happy now. They got road, right? Then another work, so we have done some kind of small work. When I was working at Government Engineering College, Tirunelveli, 3 BE civil engineering students, they have done this work. They have started this work. Then what we have done, here in the Tamarabarni Delta, this seawater is entering into the river channels and it is polluting the river channel, so that you are not able to use the water for drinking or agriculture and industry. So the local people, they have constructed these kind of temporary bunds across these river channels. During flood, all these bunds will be washed away. So people are not able to use the water. So we have collected all the data. Of course, this is the satellite image. And another beauty is they are converting salt pan, agricultural land into salt pans. Because they are getting more money. We cannot blame the farmers. They are simply blindly converting the agricultural land. You see, agricultural land here, this side. They are simply converting into salt pans because they are getting more money. So land is affected, water source is also affected, and of course they are not using the sea water directly. They are making bore wells and they are taking the subsurface water or groundwater because the salt content is more. They are getting some more salt. They are polluting the subsurface water also. This is the scenario. And finally, what we have done, so we have given this. This work is done by BE students. So we have submitted this report to the government long back in the year 2004. Say 2004 we submitted this report. Now the government is implementing this work, you see. Now they started constructing the weir at this particular. This is the success. So people will get benefit. So your research work must use the reach the society. Then one more last topic. So interdisciplinary studies. Another important, I am a mechanical engineer. I will not mingle with some other person. This gathering will be really useful, isn't it? So you can discuss with some other person who is good in GIS, who is good in Coral Draw. You can ask help. Because nowadays this is very, very important, interdisciplinary. Okay, I will tell you. See, one case study I will tell you. So this work we have done. One PG student has done this excellent work to minimize or to stop or to say mitigate the landscape. We have used this geotextiles. Kaya geotextiles is an eco-friendly or environmental friendly material to protect the slope. Okay, this is a biodegradable material. We have done experimental studies in lab, everything we have done. So we have published papers also. But what is the use? What is the use? I have to involve some other people like ECE people. What I have to do is I have to fix the sensors. Isn't it? If something is happening, so the real warning should reach the people. Like when I attended a training at Mexico, they have excellent Pacific warning system, tsunami warning system. If anything happens in Pacific Ocean, earthquake or tsunami, the real-time warning will come to the people. Immediately the people will move away from the coastal areas. So similar kind of warning system you have to develop. So by involving various disciplined people, then only I can do this. Then finally, the most important thing is you should develop contacts. This is more and more important. Okay, if you don't have contact, international contact I am telling. Suppose you are attending some conference, you must interact with the people. Okay, you must interact with the people. Then it is very, very important. Some journals, they are especially asking, native English speaking country person is there in your title of the paper or not. They will ask, suppose I am editing 5 or 6, 8 journals I am editing, very good journals. If I submit a proposal, what they will see? Immediately they will see, somebody is there from UK or somebody is there from US, then only they will approve. Then only they will approve, definitely. So you should develop the contact, this is very, very important. Then only your paper will be recognized or published, particularly very high impact journal like Nature. If you don't put the foreign authors, particularly US, UK people, your paper will not be published. You must remember this also. So like this, so we have edited so many volumes like this and some 20 articles, 21 articles in this journal like that, we have edited so many things. Then of course you can, this is my contact, it's available. If you want, you can send mails, other things. Thank you. I think I have taken more time. Thanks for this opportunity. If you have any queries, you can ask me.
So you told about many softwares, how we have to present and all
Many
those.
softwares? No.
Software?
Yeah.
But my question is, for which I have to use which software, so how can I...
It depends on your data. So what kind of output you are going to get.
Okay sir, I'll
If you
have
want
something
to
in my
do some
mind.
statistical analysis, you can use software related to the statistics.
Yeah, that's what I'm asking. What software related to statistics, that how can I find it?
SPSS is very good. You can do a lot of analysis. Or simply with the help of Excel, Microsoft Excel, you can do wonder. But your data presentation should be unique. You have to think in a different way and you have to present your data in a different way, then only it will be viewed by many people. That is more important.
Thank you, sir.
Thank you, sir.
Thank you, madam.
very much for your interesting presentation,
Thank
sir.
you, thank you.
There is no doubt in giving Venlock or Young Scientist Award for you. And we can see that you have published in high impact factor. So really, if you are presenting data like this, obviously it will be published in such a high impact factor, sir.
Thank you, madam.
Thank you very much,
Thank you.
sir.
Thank you so
sir.
much.